When the exosome is made by stem cell makes it more powerful than the stem cell itself. So when the stem cell makes the exosome, it really packs more of a punch, like 30 times more than an exosome, than a stem cell to go to fix something. Like that stem cell makes the exosome at one particular target. It puts in so many growth factors, like 3 times more than the growth factors. When the stem cell adapts, it doesn't seem to make as many growth factors into the new exosomes, and it now sets up the situation. So that first generation exosome is really best. There's really 4 or 5 things. One is an exosome will only be as good as the stem cell came from, right? That's logic. So the first thing you want to know is where did the stem cell come from? They're going to fracture of the not as convincing. Because who's failed? That person probably 20, 25 years old, 50, 60 years old. I don't want my students. I want younger students. I want really young students. Youngest to feed only for good reason. You can't control. If you ever heard about someone getting too that's a big completely uncontrollable. The other really bad thing is, let's say they came from a fetus, and that fetus was actually that long cancer, you're going to get. So you don't want fetus that's a moral argument. It's also you will get pregnant and have abortions and self fetus. So really good reasons to never have fetus. Really good this country and a lot of countries, but some are not. But they should be. I think it's very good reasons. Okay. The next best regenerated stem cell is the umbilical cord stem cell. Now you got umbilical cord blood, you got umbilical cord tissue, you got Wharton's jelly. I play mostly Wharton's jelly, which is jelly. The umbilical cord is a jelly-like substance, and it contains tons of mesenchymal stem cells that exhibit MSC. Those are my favorites. Why? Because what are the 2 types of stem cell? We're not talking fetal, right? We're talking mesenchymal, hematopoietic. Hematopoietic are great if you have lymphoma, leukemia, multiple myeloma. If you have a person anemia, you need to regenerate the blood cells, right? Doesn't matter if you want those for the bone. They're the best. But that's not us. We're looking in my line of work. I'm looking at making soup, right? I'm looking at collagen. I'm looking at skin. I'm looking sometimes joints, tendons, muscle, and sometimes heart skins. I'm looking for the MSC. Those are the ones that regenerate tissue. And in our game, aesthetics, those are the ones who don't use to regenerate our skin and our collagen, get tighter skin, so that lines on skin discolorations. The MSC stem cell. That's the best one. It's Wharton's jelly. And I'll put right up that umbilical tissue. So not umbilical blood. You don't want amniotic fluid. Those are awful. People love them because there's so many. I want to awful. Where do you think they're sitting? Maybe. That's where they're coming from. Maybe. And it does influence. The environment influences the stem cell, influences the exosome. You can influence exosomes depending upon what they're growing, what the stem cells are growing. So, number one, where did the stem cell come from? Wharton's jelly the best? Right there with the umbilical tissue. Right there. Okay. Now, number two, how do we grow? How is the stem cell growing? That means, what is the stem cell food? What's the environment? So you have an incubation tray, and you put the stem cells. That environment, that stem cell media environment, well, we call stem cell media, that'll be really good. So you need to have really good PhD that has created not a lot of people has on the fluid that the stem cells grow, that they secrete the exosomes. Those stem cells secrete exosomes, extracellular matrix, hyaluronic acid, peptides. That's what's exosomes. Just like the other stem cells. So their stem cells are secreting into the fluid that they're growing. Stem cells will create more stem cells. Those more stem cells will create more exosomes. That stem cell, okay, first generation, second generation, third generation, all the stem cells that are growing in that fluid are secreting secretomes. Some of those exosomes. How do you know what secretomes and exosomes are? Size. Exosomes go from 35 nanometers to 150 nanometers. So when we filter the fluid, we have a very fine filter We all got through that filter, those are exosomes. That's how we make it. Eventually, in the future, you will have exosomes that contain anti-cancerous type factors. I don't want to say growth factors, but uh, stuff that you're putting in exosomes specific to kill that cancer. Because one of the ways cancer spreads is by exosomes. Exosomes would go from cell to cell. So if you have cancer next, this happens. It goes to another cell, then another cell, and it spreads the cancer. So, you know, that's why people who don't know too much say, oh, I want these exosomes. Cancer. You got these exosomes. Yeah. So these exosomes take really stem cells that the stem cell. So let's go back. How do we even get the stem cell? So a healthy mother who doesn't have any disease delivers a healthy baby, right? A normal, natural child with disease. And we'll take the umbilical cord, and I'll say there's an actual service. These foods don't. The mothers have to be tested. Babies have to be tested. And if they're fine, the fluids get tested. And if they're fine, then you take the umbilical cord. And the way you actually do it, describe it. But you'll take it something you can hang the umbilical cord. So it looks like it was, and everything comes out. And then you can spin down the center and separate the different parts of the umbilical cord. And the stem cells, they're on the bottom. So you can take a pipette and just suck it out everything with what's on the bottom. And now you're going to take that and even separate that a little. Where you take, finally, you're left with a little part. Those are stem cells. Now you put that in your fluid, in your incubation tray. And look, when you find that fluid, that's what says you grow and every your exosomes, they were supreme. So when I say the very first generation is the best, that is the ninja of exosomes. That is the bionic exosome. Second's good. Third's good. Fourth's okay. Fifth and sixth, you get there. Because between the 6th and 7th generation, senescence sets it. Senescence cells, if you're not familiar with it, because senescence cell, you need to. Okay, senescence means cells are dying. They're not dead yet. In our bodies, right now, we have senescent cells. We have a turnover. We have these cells. Billions. I want to tell you, 50 to 100 billion cells a day are dying and reborn. Okay? And there's a thing called apoptosis in our bodies, right? That's the take out the trans system. So, as we get older, we have more of this senescent cells. These are cells that are dying. They're in the stage of dying. And when they are dying, they stimulate all sorts of inflammation. What is that? Disease. Why do we get old? We get more disease. Because the senescent cells stimulate more inflammation because we have more senescent cells. So what's the purpose of those things? But an old age spot, right? No spot on the skin. That's a senescent cell though. Because when senescent cells fly in the skin, they increase melanin concentration. And you see a lot of old age spots. Now that's happening everywhere. Look, you see it? What do you see? So senescent cells are everywhere. And if we just decrease senescent cells, we will live long. You know, it's great for decreasing senescent cells. Really bad. Natural killer cells. They go after senescent cells. They hate them. They hate cancer. They hate cells that don't do their job appropriately. Senescent cells because of that. I used to use natural killer cells all the time. I'd be super expensive. But they hate senescent cells. Guess what? Skippers. Natural killer cells. They really want to grow their reasons. All right, so let's see, runway. And so now, once we tested everything, including the fluid, we take the insides of that fluid and we separate that into what we want. When we get the stem cells, we like from the Wharton's jelly, which really looks like jelly, like a little pinkish red jelly. When we get those stem cells, the next part took so long to get this part. Sorry, is helpful. Is the media, the cell media, that stuff is actually, that is super important. So there are people who are known scientists, PhDs, to make a really good medium. That means no animal products in there. Because that for me, you have a whole reaction. So there are people that try themselves outside the media that stage growing because that will make a better cell, which makes better exercise. So my guy invented a way to get rid of everything filter stuff out so that the stuff that and stable. So our exosomes, so this is my exosomes, and it's, yeah, well, it's liquid, yeah. Well, we filter out everything that goes bad, if it's not frozen or kept chilled or dry ice. Stem cells have to be at -86 Celsius. I have a special freezer to keep stem cells, but that's our exosomes. So, we keep the color brown because sunlight happens to things or growth factors. So that's why it looks a little brown. But it's really clear. Gray is what I call now show me objective data. You can hear me talk, but the Carfax is what I named it. I was thinking things because Carfax X. Show me the objective data. You will not see that aside. Now track analysis. Yes, but we have there are only a few companies show it. So I want to know the objective evidence that's a nano tracking analysis from exosomes, nanometers, which are 1,000 times smaller than the stem cell So when we take nanometers and you put that on your skin, it's going to see right through the pores. You don't need to microneedle it, but it's nice to make some holes, which is not everywhere. So you make some little holes, shower your exosomes on, and they're going to sink into the holes. But even if you didn't, I use an air sprayer, and I said and I spray my exosomes on the face, and they sink through the pores. You have to be about 15 nanometers to get through the skin, if there's no pore. And there's no exosome, it's 15 nanometers. So if you wanted to get through the steps, 15 nanometers will go right. But 35 nanometers, 15 nanometers, so this will sync very nicely to where there's a port, where there's a hot air molecules, but what we're going to see everywhere. So I just spray my exosomes off, and then I do the treatments. Getting back, that's the Carfax, nano-tracking analysis. I use my surgical contact bleed treatment. I spray and apply, and then I really want to glue. This is a QC, but when I really want to hold hydration in, then I use this layer of glue capacity over the exosomes that I sprayed, the syrup, very convincing applications, and you will get a result if you will get faster. But back to this thing here. So nano-sized is just the name of a company that makes a machine that does nano-tracking analysis. That actually, most people think that that's only to show you quantity of exosomes. It is not. It actually shows you on how these lines look, the quality of the exosome. From the side, they've been born. It says, see that. Depending upon the wavelength of the laser, depends upon the part. So when you see this red one, that is an exosome. That red one is the most powerful exosome in that network. So we can see our measurements in about size, 35 to 150. Don't count anything yet to 150. See, there's 100. That's 100 nanometers. You want to draw a line in your head right down here. So everything past 150 now is all stuff. 35. That's it. Saying 18. But it's great stuff. It's just by once you still want it. So the stem cells created all this stuff, but the exosomes are from here to here. Now this picked up at least 5 different types of exosomes, or different size, let's say. And you can get a number by looking at the vertical axis, because this article is right? And here's your size and nanometers. What I want to get across to you guys is look at how this red peak went up, almost a dot, and how it came right down. That is a pure bottom. You shall see. What you usually see is something like this. You see a line go up, and then gradually fall back to the baseline. That's not a pure. This happens to be a really good company. And I don't want to tell you which one did, but it's for you. So anyway, and I used to look when you have a line that comes down. This means the product is not pure. There's a lot of other scattered different particles that this laser shining up to the side picked up. And when you don't have a pure product, that means it's a lot of different generations. And that means it's not good. It's still a decent product. It's just not nearly as good as that. You will never see a peak like that. The line goes straight up down. The purer the product, the better the product. The purer the product, the generation is probably 1 or 2. I know these guys are 1. That's what the first generation. So when I lecture about how do you decide what exosome to use for your practice, 1, where did the stem cell come from? It's been always good, right? 2, most grown is because that's what it is. That's hugely important to how healthy it is, right? 3, show me the compounds, right? Here's your objective evidence. 4 is now we got to clinically correlate. This whole first generation. Now here, hyaluronic acid, vitamin C is the main one. Okay?
Yeah.
In here, vitamin C, hyaluronic acid. There's some great amino acids that make up peptides, right? What's a peptide? Definition: amino acids in a chain or row equals a peptide. There's proline, that's my favorite amino acids. There's proline in combination with vitamin C, will grow huge long power. Okay, so now my biochemist, she takes the exosomes that we sent her, and she developed a cocoon, and the cocoon is to protect our exosome. So make sure that it remains stable room temperature, which on stage 2 years anyway, but to protect it so it doesn't open. Because what is an exosome? It's a vehicle for transport. Like an exosome is important by the passengers things. Exosome only looks like a little circular, right? It's a little circle, but what does it contain? A messenger RNA is the message. A really good stem cell made a really good message and taught it in the message how to make a bad cell an insect. How to make bad skin insect. So that's the message. So now who's going to carry out all that work? Well, the construction workers, the growth. So the stem cell put the message, messenger RNA, into this vehicle to transport, more like an organ. So that exosome's really like an organ. So now the stem cell says, okay, where's all my construction workers? Puts 1,000 of them in there. Now that exosome has just carry out the plan, like an architectural engineer's plan. Now it's got all the construction workers. You already exosome. Now that exosome leaves the stem cell, it's in here. Well, we wanted to protect it and make sure it gets to its destination. So if your Uber car stops a while early where it wants to go, what would you do? So what we have here is two peptides that are protecting our exosome to make sure it doesn't open up until it gets to the deep dermis. So our exosomes are sinking into our pores. We have a really inclusive layer of vitamin C and hyaluronic acid that glides on, so inclusive, so great for wounds too. So when you do this, right now the exosomes are sinking in, they're protected. And when they get to the deep dermis, they're looking for one thing. Those are fibroblasts. And so when we get to the deep dermis, our cocoon opens up, releases the exosome sees right here, it opens up, and it regenerates and renews fibroblasts. Fibroblasts are the skin stem cells. They're the precursor to new skin. So when you have new fibroblasts that rise in the earth, you get new skin.